As we're working with logarithms, there are several logarithmic properties that help us solve more complex looking equations. Let's take a look at those, starting with listing out what properties we're going to use. The first property we've already seen before, and it's called the exponent property. And that's when I've got the log base b of some number raised to an exponent. We know that exponent can move out in front of the logarithm. So we've got m times log base b of a, and often that's easier to solve for the exponent. But because logarithms really are exponents, just written in a different way, we have several properties of logarithms that are similar to exponent properties. The first is the sum of logs property. And that is if I've got the log base b of, we'll call it x, and I want to add to it the log base b of y. When we're adding two logarithms together, we can combine them into a single log where we multiply their insides, x times y. Similarly, if we have a difference of logs, where we have log base b of x minus log base b of y, we can combine those into a single log with base b, where we divide x by y. These three properties allow us to simplify or expand expressions to make them easier for us to use and solve equations. Let's look at how we can use the properties. The first example of how we're going to use the properties, starting simple, is if we wanted to simplify maybe log base 3 of 5 plus log base 3 of x. And I can see since I'm adding two logarithms together with the same base, we can write them as a log base 3 and then multiply the insides together to get 5x. We can make this a little more complicated by doing log base 7 of 5x to the 9th plus log base 7 of 2x cubed. And what I can do here, again, because I'm adding two logs of base 7, we can multiply the insides together. 5 times 2 is 10. And then we're multiplying 9x's and 3x's, which means we've got a total of 12x's that are multiplied together. The subtraction log property works very similar. If I've got log base 4 of 12 and I want to subtract log base 4 of 2, when we're subtracting two logs, we can say that's log base 4 of, and we can divide the numbers. 12 divided by 2, which we know is 6. Again, I can complicate it a bit by doing log base 8 of 18x to the 5th and subtracting log base 8 of 3x squared. Again, we know that means we have a log base 8, and then we divide the numbers because the logs were subtracted. 18 divided by 3 is 6. And if we have 5 x's and divide out 2, there's only 3 x's left, so log base 8 of 6x cubed becomes our simplified form. We can even use the rules in reverse. I could take something like log base 5 of x cubed y to the 6th over z to the 4th, and we can expand this where each factor gets its own log. First, we would have the log base 5 of the x cubed, which is multiplied by the y to the 6th, which means we're going to write it as a sum, and add log base 5 of y to the 6th. Then we see the division of z to the 4th. When we're dividing inside a log, that's the difference property, so we'll subtract log base 5 of z to the 4th. And then we can even use the exponent property and move each of these exponents out in front of their respective logs to get a final expanded answer of 3 log base 5 of x plus 6 log base 5 of y minus 4 log base 5 of z. So that's kind of how we can use the properties. We can expand a log to make it bigger. We can contract a log to make it smaller. Just remember that when we add and subtract logs, they become products and quotients inside of the log. And the whole reason we have these properties is to help us solve log equations. We've already seen problems like log base 2 of 3x minus 7 equals 3. And when there's only one log like this, we know we can rewrite it as an exponent and get 2 cubed is equal to 3x minus 7. Simplifying 2 cubed, we get 8 equals 3x minus 7. And this will give us a simple two-step equation which we know how to solve. Adding 7 to both sides to get 15 equals 3x, and dividing by 3 to get our final answer of x equals 5. That we've done before. What we want to do now is see how these log properties can help us with solving equations. If we had log base 4 of x minus 3 minus log base 4 of x plus 1 equals 2, this problem we can't just rewrite as an exponent because there's 2 logs instead of a single log. However, these log properties that we just started looking at allows us to change the subtraction of 2 logs into a single log base 4 where we divide the innards. The x minus 3 is divided by the x plus 1. Equals 2. Now that we have a single log, we can rewrite it as an exponent. 4 squared equals x minus 3 over x plus 1. And simplify 4 squared to 16 equals x minus 3 over x plus 1. And then we just have to solve the resulting equation for x. Let's get rid of the fraction by multiplying both sides by the denominator of x plus 1. When I do, we can distribute the 16 through, giving us 16x plus 1 times 16 is 16 equals x minus 3. I'll get all the x's on one side by subtracting x from both sides. 15x plus 16 equals a negative 3. Subtract 16, 15x equals negative 19, and finally divide by 15. And we end up with, as we run out of room, x is equal to negative 19 over 15. And so that's how being able to change 2 subtracted logs into a single log can help us go through and solve the equation. That one had a minus. Let's try one with a plus in it. Let's try the log of x plus 2 equals the log of 5 plus the log of x. You might notice I didn't write a base. That means we're going to assume the base is 10. And here we've got 2 logs added together on the right side. We know if 2 logs are added together, then they become a product on the inside, 5 times x. Now we've got 2 logs that are equal to each other. If the 2 logs are equal to each other, we can exponentiate both sides, which means we take the base of the log and make it the base of the entire problem. That way the logs and the bases disappear, which essentially accomplishes making the insides equal to each other. So x plus 2 is equal to 5x. Get all the x's on one side by subtracting x, and 2 is equal to 4x. Divide both sides by 4, and x is equal to 1/2. Because we were able to write the sum of two logs as a product in one log, we were then able to go back and solve the equation. So these properties that we talked about are going to be really helpful to us so that we can simplify expressions and make them something that we can actually work with and solve. Best way to get good at them is to practice on your own. So go ahead and start working on these, and we will see you in the next video.